When it comes to building APIs and services, my go-to language of choice is, well, Go, and for good reason. Personally, I find that Go strikes a decent balance when it comes to safety, performance, and ease of implementation. And whilst it may not be as good at some of these compared to other languages, I find that when it comes to being pragmatic, then Go is a language that really shines. Despite this pragmatism, however, there is one area that I find Go to be less ideal when compared to other web-focused languages, specifically when it comes to auth. If you take a look at other web-first languages, such as Ruby with Ruby on Rails or PHP with Laravel, it's incredibly easy to set up a project that has authentication built in. However, when it comes to Go, the same can't really be said. Whilst the Go standard library does provide a couple of packages that can be used for authentication primitives, things such as password hashing and OAuth 2, these are by no means a complete auth solution. Now, I know what you're thinking. Comparing the standard library of Go to these more full-featured frameworks, such as Rails and Laravel, isn't exactly an apples-to-apples comparison. And you're right. However, even when you consider third-party packages available to Go, the situation is still kind of bleak. The best package that is available for Go is probably AuthBoss, which, to be fair, is pretty feature-full. However, it unfortunately requires you to set up a lot of the integration yourself with your own system, including things such as database storage and API endpoints. Now, this isn't exactly a bad thing. However, when you compare it to another open source package that I've been using recently, Better-Auth, then the difference is night and day. This is because Better-Auth makes it incredibly easy to add authentication into your application that works with your API layer, your front end, and even your chosen database and its driver, without you needing to write any of the implementation yourself. In addition to this, Better-Auth also makes it incredibly simple to add other auth features into your application, things such as two-factor authentication, one-time passwords, and organizations, through its fantastic plugins system. Now, to be fair, all of these features are available if you happen to use a third-party auth provider with Go, such as Clark or Auth0. However, unlike these platforms, which can sometimes cost an eye-watering amount, for example, two-factor authentication support on Clark is $100 a month, Better-Auth allows you to have all of this for free. If that wasn't good enough by itself, however, the plugin system also provides other features that can often be tedious to implement when building a new SaaS product, one of which is handling payments, as there are both plugins for Stripe and Polar.sh, which handle all of the complexity around products, checkouts, subscriptions, and even webhooks. All of this not only makes Better-Auth my favorite auth package, but it's perhaps my favorite library when it comes to building a SaaS product. However, there is unfortunately one catch. Better-Auth isn't available for Go. Instead, it's only available for TypeScript. Now, for some people, this isn't too much of a problem, but for myself, it presents a bit of an issue, as whilst I currently do use TypeScript on the front end with Next.js, I still like to use Go when it comes to back-end services such as APIs or other systems. So what is a mixed language full-stack developer to do? Well, one option is to just stop using Go, and instead use TypeScript on the back end. Whilst I have been tempted a couple of times to do this over the past few weeks, I fortunately haven't yet needed to do so. This is because it's still possible to use Better-Auth when it comes to a Go backend API, thanks again to its fantastic plugin system. However, knowing how to set this up can be a little elusive. In fact, it's actually something I've been asked a couple of times already on social media. Therefore, I thought it would be a good idea to do a video looking at how to set up Better-Auth when it comes to working with Go. Before I show you how it's done, however, let me first take a quick minute to ask you a couple of questions. The first of which is, are you interested in learning back-end web development with languages such as Go or TypeScript? And the second question is, do you like playing RPGs? If you answered yes to both of these, then you're going to love the sponsor of today's video, Boot.dev. Boot.dev is an online platform to help you to learn to code, using back-end web technologies such as Go and TypeScript. However, rather than being your typical e-learning platform, Boot.dev instead does so by taking inspiration from good old-fashioned RPGs. By learning on Boot.dev, you'll earn experience points, levels, achievements, and complete quests, in order to get to the top spot of the global leaderboard, all of which makes you feel like you're playing a video game, but with the added benefit of learning at the same time. If you're not too sure whether or not boot.dev is going to be right for you, you can try it before you buy it, as boot.dev is free to read and watch in guest mode, and by having a paid membership, it unlocks all of the interactive features found on the course platform, such as hands-on coding, AI assistance with Boots, the AI wizard bear, progress tracking, and other game mechanics. If all of that sounds appealing to you, then you can use my coupon code DREAMSOFCODE to get 25% off your first payment, whether that's a 1-month subscription or for a whole year. So to get started building back-end web technologies using either TypeScript or Go, then visit boot.dev using the link in the description down below. And make sure to use my coupon code DREAMSOFCODE in order to get that additional discount. A big thank you to boot.dev for sponsoring this video. So now let's take a look at how we can get Better-Auth working with a TypeScript frontend and a Go backend. The first thing we're going to need is actually a TypeScript server with a database connection. Fortunately, this isn't as tricky as it might seem, especially if you're using a meta framework such as Next.js, Nuxt, or Solid Starter. In my case, I like to use Next.js with Drizzle, which has great support for Better-Auth and also allows me to export database migrations, which is really useful when working with SQL-C. However, if you're using just a front-end framework by itself, so something like React, Vue, or Solid, you're going to need basically a dedicated auth server, powered by something like Hono or similar. Personally, I would only really recommend using this approach with a meta framework, just because it's a lot easier. In any case, with your TypeScript server selected, the next thing to do is to install Better-Auth. This step is basically following the installation documentation, which is pretty easy to navigate. For a really quick vibe coding approach, you can basically paste in the URL of Better-Auth into Claude Code, and it will go ahead and set it up for you. Although I do recommend doing this by hand the first time you do it, just to better understand it. For this video, I've gone ahead and created a sample project just to be able to show the key points of what you need to change and implement. This project contains 2 applications. The first is the Next.js application, which has both Better-Auth and Drizzle already up and running. The second application is the Go API, which we can use to test authentication once we've integrated everything together. You can find a link to this code in the GitHub repo down below, if you want to try it out yourself. If I go ahead and run both this app and the API, you can see that I can open up the application at localhost 3000 and log in with an account I created earlier. On the homepage, I'm able to test whether or not authentication is working with the Go endpoint by clicking this button, which, as you can see, returns that I'm currently unauthenticated. If we quickly take a look at the source code, we can find the Better-Auth configuration is inside of the source/lib/auth.ts file, with the associated Drizzle schema inside of the source/db folder. Okay, now that we've reviewed the sample app and taken a look at the Better-Auth configuration, the next thing to do is to begin setting up Better-Auth to work with Go. But how to do so? Well, the easiest way to achieve this that I've found is to make use of another one of Better-Auth's plugins, specifically the JWT plugin, which we can use to generate JSON Web Tokens for authentication with our Go API. If you're unfamiliar with JWTs, they're basically a self-contained JSON-encoded token that includes both user data and verification through a cryptographic signature, which makes them pretty perfect for authenticating across services, such as what we want to do. In our case, we'll use this JWT to not only prove that the user has been authenticated, but to also pull out some of the user's information, including their ID, their name, and their email address. By the way, if you want to learn more about authentication with JWTs, then boot.dev does have a dedicated module inside of the course on Go authentication, just FYI. Okay, now that we know what the game plan is, let's go ahead and execute it. To add the JWT plugin to Better-Auth is incredibly easy. All we have to do is import the function and add it to the plugins array in the Better-Auth configuration. Then we can go ahead and run the Better-Auth CLI generate or migrate command, depending on your own setup. In my case, because I'm using Drizzle, then I just need to run the generate command, which will generate a new schema. With this new schema generated, I can then migrate these database changes by using the bunx drizzle push command, which will go ahead and migrate the database schema for me. One thing to consider here is whether or not your auth server should share the same logical database as your Go API. In some situations, it might be easier to use a separate DB for auth. However, most of the time, especially on smaller applications, you're probably going to want to reconcile them. This is perfectly viable to do, but it does require a little bit of work depending on your setup. If you're interested in how to do this, then let me know in the comments down below, and I'll do a video looking at how to have both Go and Drizzle working together with the same database and migrations. With the JWT plugin added into the Better-Auth configuration, the next thing to do is to send up the JWT token to our Go API. In order to do so, we have a couple of different approaches that we can take, each with their own pros and cons. We'll take a look at some of these approaches later on in the video, including the one that I personally prefer to use. However, for the moment, we're just going to take the most simplest approach, which is to obtain the token on the client and send it direct to the API. In order to do so, the first thing to do is to add in the JWT client plugin into the auth client configuration. Upon doing so, we then have access to a new token method inside of the auth client, which we can use to pull out a JWT token from our auth server. With the token acquired from the auth client, we can then go ahead and pass it into the authorization header of the request as follows, giving it the bearer prefix. This means we're now able to access this token from the request headers inside of the Go API. In order to do so, if we head on over to the auth.go file inside of the auth package of the Go API, here I have a function called user_from_request, which takes an HTTP request and returns either a user or an error. Here is where we want to implement the parsing for our JSON web token. However, rather than doing this by hand, I'm instead going to use what I think is perhaps the best package when it comes to working with JSON web tokens and related technologies in Go. This is the JWKS package by Lestrurat-Go, which provides various functions for working with various JWKS type technologies. In our case, we're going to work with JWTs and JWKs. To do so, let's go ahead and add the package using the following go-get command. Then, in order to parse the JWT token, we can use the parse request function of the JWT module provided by the package, which will return either the parsed token or an error if something went wrong. More on that shortly. With our token now parsed, the next thing we can do is obtain the user ID. By default, when using Better-Auth, this is stored inside of the token's subject. Therefore, we can pull it out by using the subject method of the parsed token, which returns a string and a boolean, letting us know whether or not the subject claim exists. With that, we should now be pulling out the user's ID from the JWT. However, before we take a look at how to pull out both the user's email and the user's name, let's first make sure that our JSON parsing code is working correctly. In order to do so, the first thing we need to do is restart the server, which I could do using the go run command. However, it's instead going to be more efficient to use another CLI application called Air, which performs automatic live reloading of Go applications whenever you make a code change, which is going to come in handy throughout this video. With the server restarted, if we head back on over to the Authly application and click the Test Go API button again, you can see we're still getting back an error. If we take a look at the application logs, we can see the reason for this failure is due to the fact that there were no verification keys provided, which means we weren't able to verify the token's signature. This is a really important step when it comes to using JWTs, as it ensures that the token that you're parsing was in fact created by your authentication server, and without it, the token can effectively be generated by anyone. We'll take a look at how to verify this signature in a minute, but for the moment, let's go ahead and bypass this verification step just to test that our JWT parsing is working correctly. We can do so by adding in the following option of JWT with verify to the parse request function, making sure to set the value to false. Upon making that change, the application should now automatically restart thanks to Air, which means we can go ahead and test it out. This time, when I click the test button, you can see it works, both returning a successful status and the user's ID. Okay, so now that we're parsing the JWT correctly, let's go ahead and rectify the issue where we're not verifying whether the token was signed by our auth service. In order to do so, we need to have access to the associated public key that was used to sign this token by Better-Auth. But how do we do that? Well, we could pull this out from the database table where the JWKS is stored. However, this isn't exactly the best approach, especially as there may be times where this database isn't shared across each service. Fortunately, there is a much easier approach, as Better-Auth makes this key set available through an API endpoint when using the JWT plugin. This endpoint is found at /API/auth/JWKS. If I go ahead and make a curl request to this endpoint, you can see it returns the key sets in the form of a JWKS schema. So with this endpoint available, how do we go ahead and make use of it inside of our Go API? Well, fortunately, that's where the JWK module of the JWX package comes in handy, as it provides a function called fetch, which we can use to both download and parse the key set from our auth server. In this case, I'm hard coding the API URL, but in production, you'd likely want to make sure that you can override this base URL using something like an environment variable. In any case, with the key set obtained via the fetch function of the JWK package, we can then pass it into our parse request function as an option using the JWT with key set function, replacing the with verify false that we had before. Now, if we go ahead and test the Go API again, you can see we're still getting back a success. However, this time we're not bypassing the verification, meaning that our authentication code is now considered secure. One thing to note, in a production setting, you'd likely want to use the cache type of the JWK package, which will allow you to effectively cache the JWK rather than fetching it every time. Okay, with our token now verified, let's take a look at how to obtain the other two user properties from the JWT, of the user's email and name. In order to do so, if I quickly print out the JWT, copy it to my clipboard, and then paste it into jwt.io, we can take a look at the decoded payload of the JSON Web Token, which, as you can see, provides a number of different JSON properties or claims, including my user's name, which is Dreams of Code, and my user's email, which is test@dreamsofcode.io. In addition to these two properties, you'll notice that our JWT also contains other user information in the claims, such as email verified, image, created and updated at, as well as the user's ID, which is the same value as found in the subject. So as we can see, both the name and email are available inside of the JSON Web Token payload. So how can we obtain these values inside of our Go code? To do so, we can use the get method of the parsed token, which will allow us to extract the value of any claim, including non-standard claims, out of the token. Therefore, let's begin by defining two variables that we can store these values in, one for the email and one for the name. Then we can use these values with the token.get method in order to pull out the email and name respectively, passing in each value we want to store it in as a pointer. Once that's complete, we can then go ahead and assign them to their respective properties inside of the user struct. Now, if we head back on over to the application and press the test Go API button again, this time we can see that both the email and name are being returned inside of the API response. With that, we've managed to set up the Go API to be able to pull out values from the JSON Web Token, as well as verifying that it was signed by the Better-Auth API server. However, as I mentioned, there's actually a caveat with the approach that we're currently taking, as for each request that we send to our Go API, we're actually making two. One to obtain the token from the auth server, and the second being the actual request that we send to the Go API. Whilst this works, it's not exactly the most efficient approach we can take. So let's take a look at a couple of other options we have when it comes to sending authenticated requests. Either sending it client-side, which we're doing already, or sending it server-side. We'll take a look at how to send authenticated requests server-side later on, but for the meantime, let's take a look at how we can improve the efficiency when it comes to client-side requests, which, in a word, is basically caching. This means rather than obtaining a token every time we want to make an authenticated request, we instead obtain it once and cache it until it expires. When it comes to setting up caching, there's a couple of different approaches that you can take. If you're using Axios, then there's the Axios JWT package, which will not only refresh the JWT for you, but it will also add it to the authorization header of any requests automatically. Another option is to use Tanstack Query, which also allows you to set up automatic refreshing of JWTs. In my case, however, I'm just using the Fetch API. However, it's still possible to add token caching to this. In fact, I've already gone ahead and done a simple example on how to do so. The way that it works is that I have a cached token property inside of my API client, which is either a string or null. Then I have a new method called getToken, which first checks to see if the cached token is valid, i.e. it both exists and is unexpired, and if that's the case, it'll then return it. Otherwise, it requests a new token from the auth server, followed by caching that and returning it back to the caller. Therefore, in order to use this, I can just go ahead and replace my call to the token method of the auth client with a call to getToken instead. Now, to test this, if I head on over to the Authly application again and refresh the page, if I open up the network inspector, we should expect to see the first call hit the token endpoint before the verify one, which, as you can see, it does. Upon doing so, the token should now be cached, and we should only see direct API calls to the verify endpoint instead of the token, which, as you can see, is the case, letting us know that the token caching is working. When it comes to caching the JWT on the front end, you may be tempted to store this inside of either local storage or session storage. However, I would recommend not doing either of these, as it can cause your site to be susceptible to cross-site scripting. Instead, the securest places to store these is either in memory, as I'm doing already, or inside of an HTTP-only secure cookie, which can only be set by the remote server, and therefore would require a custom endpoint in order to achieve this. Another caveat when it comes to client-side requests is the fact that your server also has to support CORS, i.e. cross-origin resource sharing. In my case, I'd already set this up inside of the Go API, which you can see inside of the main function. Here, I'm just using the CORS.allowAll.handler function to basically accept any domain. This works for development, but when it comes to production, you would most likely want to constrain this. Because of this requirement of CORS and having to store the JWT on the client, then this approach of making authenticated JWT requests direct to the Go API isn't actually my preferred approach to take. Instead, I much prefer to make authenticated requests from server to server. This not only means that you don't have to worry about safely storing a JWT on the client, but it also means you can make authenticated requests when working with React server components, or when working with an API, such as with request proxying. So let's take a quick look at how we can make an authenticated request from server to server. If I head on over to the page.tsx, which is a React server component inside of Next.js, let's go ahead and look at how we can obtain a token similar to what we were doing with the auth client. When it comes to interfacing with Better-Auth on the server, this is similar to how you would on the client, but it has a couple of key differences. To begin, let's go ahead and obtain the token as follows. However, rather than using the auth client like we were doing on the front end, we instead use the auth configuration with the API field inside, which is how you access the Better-Auth endpoints from the same server. In our case, the function that we want to use is the getToken method. However, in order for this function to work, we need to pass in the request headers that came from the original client request, which we could do as follows. Now, if I go ahead and log this token and quickly refresh the page, we can see that our server has access to the user's JWT, which means we could basically use it how we were on the client, sending up a fetch request to our API's endpoint, passing this in as the authorization header. For example, if we want to go ahead and obtain the user's details using the same API/auth/verify endpoint, we can do so as follows, making a fetch request to the Go API server, passing in the same authorization header. Then I can go ahead and use this JSON response. Say, let's go ahead and do UserID, and we'll pass in the data.user.id property. Now, as you can see, the user's ID is being rendered whenever I refresh the page, as it's being rendered on the server rather than being rendered on the client. By using this approach, it not only allows us to make authenticated requests from React server components, but we can also make these requests when it comes to server APIs, which actually enables my favorite approach when it comes to sending authenticated requests. This approach is to basically perform request proxying. So rather than the client sending a request direct to the Go API, it instead sends it to the Next.js server, which will then forward it on to the Go API in the backend. This provides a couple of key benefits. The first is that the JWT never comes back down to the client itself, which makes it slightly more secure. The second main benefit is that you don't need to set up CORS on your API server, which is something I like to avoid whenever possible. And lastly, there's no need to implement any form of token caching, such as the implementation that we saw before. Despite these benefits, however, there is one major caveat when it comes to request proxying, in that you're basically doing a double hop from your front-end API to the Go API itself. However, this is only really an issue if both of your servers aren't co-located in the same place, or if you happen to have any bandwidth constraints between the two, such as if you're using a serverless platform like Vercel or Railway. Because most of the time I like to keep my servers co-located, and because I prefer to use a VPS, then these caveats aren't too much of an issue when it comes to my own situation. In any case, to show how this works, I have the following API route set up in my Next.js server, which will catch any requests that are sent to the /API path and proxy them to the Go API server. Adding authentication to these proxied requests is pretty much the same process that we've seen already. First, obtaining the token using the auth API get token method, passing in the request headers as follows. Then, with the JWT in hand, we just need to set this as the bearer token in the proxied requests authorization header. Now, in order to use this, instead of sending the request direct to the Go API server, I can instead send it to the /API path of the same host, in this case /API/me, which will proxy it to the Go API at the same path that we were using for the authorization. This /API/me endpoint uses the exact same handler as we saw on the verify endpoint earlier, but is just used to deconflict with the /API/auth endpoints, which are used by Better-Auth. Now, if I head back on over to the Authly application and click the Test Go API button again, you can see it still works. However, this time, because we're proxying the request through the front-end API, then we don't have to deal with any cause issues, and we're not exposing the JWT to the client in any way. With that, we've managed to take a look at how I like to use Better-Auth when it comes to building full-stack applications, with a Go API and a front-end framework using TypeScript like Next.js. This approach has allowed me to continue using the language that I most prefer when it comes to building back-end services, Go, whilst still being able to use what I think is the best authentication package out there. However, that being said, if TypeScript keeps getting packages that are as good as Better-Auth, then perhaps maybe it's just a matter of time before I end up switching over. In any case, whilst we're on the topic of both TypeScript and Go, I want to give a big thank you to today's sponsor, boot.dev. If you're looking to learn how to build back-end web services using either TypeScript or Go, or even both, then I recommend checking them out. And they even have a course on authentication which covers JWTs in perhaps more detail than I've done in this video. So if you're interested, make sure to use the link in the description below, and if you want to get 25% off your first purchase, then make sure to use the coupon code DreamsOfCode. Otherwise, I want to give a big thank you for watching, and a massive thank you to boot.dev for sponsoring this video. I'll see you on the next one.